look like you were like in the middle of it. I would like Andrew. Don't have space. Usually we'll stand up. Yeah.
All right, so thank you all for coming. My name is Amit. I'm the events lead for CDS, and we are very excited to be doing this event. It's the first time we've ever done anything like this before, and we also have some very unique material in this three-part session. We have material that is actually never taught in any Cornell course. This is the only place where you can get this information. All right, so I'd like to introduce our two instructors today. We have Daewon Kim, who is the instructor of Info 1998, our course about data science and machine learning. He is an MEng student who's graduating this year. We also have Nolan Gray, who is the operations lead for CDS, and he's a sophomore studying computer science. We also have a TA, Cameron Ibrahim, who's going to be walking around. If you have any issues installing Hadoop, Spark, Linux, anything like that, any questions, any issues, just raise your hand. He'll come over and help you out. Okay, so without further ado, let's get started. Please welcome Daewon Kim.
Can everyone in the room hear me? Is my mic working? Cool. Okay, so we're really excited. We didn't anticipate this event becoming this popular. So we're really nervous about this, but let's give it a go. So, to give a little bit of an introduction to who we are. So we're from Cornell Data Science. We're an undergraduate project team. We participate in various data science competitions and natural language processing, deep learning. How many of you have attended info sessions or are part of the training program? No? Oh, some. Okay, cool. So my name is Daewon Kim. So I participated in Cornell Data Science for 2 years now. So I graduated, and I really wanted to have this parallel processing and my knowledge of Spark be passed on to people in the core team. And then we thought, why not expand it to everyone so that the Cornell community in general knows how to use parallel processing software. Props to Nolan. So Nolan was just a freshman last semester, last year, and he really has risen up to the challenge of becoming a leader in the team. And he will be doing more of the lecture or the instructions for the second lecture. So we're going to talk a little bit about, in the later slides, how the structure of our series is going to be. But he will be doing more on the second one. And today I'm talking more about the intro setup to what we're going to be doing. All right, so I would like to take a little bit of time right now. So go to that link. And this will be the primary. So are people familiar with Slack? It's like a chat app. And what we're going to be doing is, because we have such a big crowd and we have a limited number of TAs who can help out, you guys can post questions or screenshots to the Slack, and there will be a channel called questions, and we'll be able to address your questions directly so that one person can attend to more problems. So can you do that real quick? Yeah. So the good thing about Slack is you can post wherever you want. You can share things and post memes. Well, don't do that. Don't post memes. All right. So while you guys are doing that, I'm going to quickly move over to the next slide. Has everyone seen the link? They're all good? Cool. Okay.
At the bottom of the screen it says, if you have a @Cornell email address, you can create an account. Click that part.
Yeah, so at the bottom, there's a specific link that says if you have a Cornell email, you can create an account. So it's open to everyone who has a Cornell email. If you don't have a Cornell email, come talk to me, I guess. But it should be interesting. Yeah. So to give you a little bit context of why we decided to go into parallel processing at all is because our team actually has 4 servers, and we're expected to have 3 more, and we'll have about 100 CPU cores to work with, and a lot of the data sets, or some of the data sets that we're working with, are on a scale that will crash laptops regularly if we do any kind of operations. So we really need to work on parallel computing. So it says here, we have servers that have equivalent to 25 laptops with CPUs, 60 laptops in RAM, 60 laptops in disk space. This is a bit of a bragging slide that we use in the info session, but we basically are using servers. We need to know how to use the servers, how to use certain software. So today we're going to talk about Hadoop. And over the series, we're going to talk about specific software platforms we're going to use. All right, next one. All right, so let's talk a little bit about logistics. Can you dive to the next one? So what we will cover. So we have 3 parts, and the thing is, these are kind of build-ups. So we strongly encourage you to attend all 3 if you can. If you can't, we will try to accommodate you as much as possible by using video recording. And but the part about that is that you won't be able to actually interact with us and ask questions. And specifically for the installations today, you really need help with the installations. Okay, so part 1 is going to be, we're going to briefly talk about what parallelism is, or what sort of examples of parallelism are there. We're going to install Linux onto your computer. So if we're going to make everyone sort of dual boot. We're going to encourage everyone to dual boot. So have 2 OSs on their laptops if they haven't done so already. And then we'll basically run through Spark and Hadoop workshops, Spark and Hadoop installations. And Spark and Hadoop are the platforms that we're installing. We will be sharing with you, if you're on slide, we'll be sharing you the installation guide very soon. Part 2 is going to be the actual theory and the basic usage. So we're going to introduce the architecture of Hadoop. What is Hadoop? What is Spark? Why do they matter? And why is it useful? And so we're going to talk about the actual architecture, the structure. So today's just actually the setup. And I apologize in advance that it will be drier. So today's session will be a little bit dry because a lot of times we'll be installing stuff. But trust me, if you guys install this on your own, you'll be spending at least a week or 2. First time I ever tried installing Hadoop and Spark, it took me 2 weeks. So we're here to basically share experience and advise you guys when troubleshooting events come up. So the third one is, we're actually going to dive deeper into a specific software called Spark. Please quiet. Okay, part 3 is going to be, we're actually going to do implementation. So the actual Spark syntax, so we'll be using something called PySpark, which is a Python API for Spark. And we'll show actual code, and we will learn how to implement, and we will learn how to optimize. So there are different tricks to optimizing Spark the Spark process. Okay, next one. So today's session is going to be, I'm going to talk a little bit about parallel processing. This is going to be brief. I'm not going to go really into detail. We're talking really about just data processing. And then we're going to install Linux. So we're going to install Ubuntu. And then we're going to talk a little bit about Linux basics, so basic commands. For those of you who are familiar with Linux, this will be quite repetitive and just very, very basic. But we just want you to be able to install and understand what's going on. And I will basically talk about how the installations work for a brief period of time, and then I'll show you a demo I'll show you a demo of Spark and sort of the implications of what the demo is. And then after, so that's going to be basically the first half. So, and for the second half, you guys are free to go if you already have it installed, and you guys just know what to do. But for the later half of today, will be spent you just basically installing, and if you have problems, we will help you. So the installation process is quite lengthy, it can be complicated, and it can be quite, there can be a lot of problems. And it's case by case, so it really helps for you to get guidance from some people who've done it before. So that's the second half. So the first half is lecture, second half is going to be installations. Okay, so let's talk about parallel processing. So what is parallel processing? It's quite simple. It's basically processing things that you would otherwise run in a sequence. You break it down into sub-processes that can be run concurrently. So this is a good sort of, I guess, visual of how that works. You chop up the problem into small components. So this would be sort of the mini version of that big task that can be run concurrently. And then you use your processors, basically your CPUs or GPUs or whatever processor that you are using, to run this task concurrently together. So rather than running one processor on that entire problem, you break it down and run it on 4 processors. And this is relevant to you guys, as most of you guys have 4 CPUs in your laptop. Okay. So when to use parallel processing? One, obviously, when the things that you have to work are very large. So if your data set is just huge, and you really can't do much with just one core. Actually, against intuition, it also is useful when you have a lot of resources. So if you have like 100 CPUs to work with, like we do in CBS, it's really just advantageous to parallelize your operations, because the number of cores you have may become a bottleneck. So why not just parallelize and chop it down and finish it in 100th the time if you have 100 cores. And the opposite is true when you don't have much resources. So for a lot of you, if you get onto the Cornell data science core team, you'll be able to use the servers. But for those of you who will be using your laptops to do your data science or get introduced to data science, this is quite relevant. You won't have much resources. You're confined by the resources of your laptop. And your laptop has at most 4 cores or 4 logical cores. High time complexity. So if your operation, so how many of you have taken Java or know object-oriented programming? Okay, cool. So even if you haven't, it's fine. Basically, if your operations have very high time complexity, so what that means is your problem, the things you have to process, your computation scale quite, how do I say? Your computation scale up really fast with the scale of the data set that you have to process. That's called high time complexity. And if you have something that has high time complexity, you want to somehow make it more manageable by parallelizing your operations. So things that are lengthy processes become shorter. So this is pretty intuitive, but I thought it would be good to know. Okay, good. So this is sort of an aside, but it's a good point to know. So when we say parallel, I'll mention things like embarrassingly parallel or inherently sequential. So embarrassingly parallel is when the entire process can be broken down. So a good example, I'll be using this example later too, is adding 2 to all elements in an array. So if you have an array, or another way to say it is a list, or a vector of size, let's say, 1,000,000, or 1,000,000,000, let's say, and you want to add 2 to all elements, you can, if you had 1,000,000,000 cores, you could basically parallelize it into 1,000,000,000 processes, concurrent processes, where each unit just adds 2 to the element that was given. So that's sort of the idea of embarrassingly parallel. You can parallelize your operations and run it concurrently. Inherently sequential is when the entire process can only be done in sequence. Pretty obvious. Just generating a sequence with a set rule. If you are generating a Fibonacci sequence where you have to add the 2 elements before, you can't generate a number somewhere down the line first before you generate the numbers before. So that's how it works. All right, so some ways that big data, so when I say parallel processing, there can be so many different applications of parallel processing, but we're specifically talking about data processing. There are other ways to handle big data. And one way is you want to, usually the step to do it is to make your process objects smaller. So how can we do that? So let's think about ways to break down or make your objects smaller. One is filtering. So maybe you have information, you have the census data of the entire United States, and you want to look at just California. What would you do? You basically filter in terms of the states, and that would reduce the number of rows you have. So that's one way you make your object smaller. Second is subsetting. Oh, that's missing the parentheses, but okay. So subsetting basically is for example, just cutting down the columns. So maybe you want to just look at the state column for some reason. So in that way, maybe you have 100 columns. If you just select one column to look at, you just reduce your data set size by 100. Breaking down to subtables and join when needed. So this is the idea of a relational database. So for example, the data about me could be stored in different locations. So for example, let's say Cornell wants to store data about me, and the physical education department could store some information about the PE courses I took or the requirements I've done in a separate table, and the engineering advising office could be storing a table somewhere else. And that way it's more convenient. I don't, any one location is not required to hold all the data. So the objects they are dealing with are smaller, so that when computations actually occur, they don't take up huge amounts of space. Sampling. So if you have 1 million data points, sometimes if you want to run some kind of models or computations, you might want to do it in a sample. So maybe just sample 10% of data. And in industrial scale, maybe 1% or 0.1% of your data. Then sampling could be, if given that your samples are a good representation of the data set, is it okay? You want the screen on? Yeah. Right, sorry. Sampling, so the tricky part about sampling is, like I just said, making sure that your samples are a good representation of your population. Sometimes, for example, let's say you want to do some cancer diagnosis data, the people who get diagnosed with cancer are really, really small, so that means your data set has a huge skew. In that case, sampling can be very tricky. So there are different techniques of doing that. You oversample one group, or you do stratified sampling where you sample only a fixed amount from both groups. So the sampling methodology actually affects the performance of your models a lot. So the sampling part can be very tricky, but that is also one way of doing it. Okay, so parallel execution examples. I want to talk here a little bit, some parts. So how many of you use Python? Right. Python? R? Okay, cool. So Python and R, and I'm going to give you a quick Linux example of how this works. So OS parallelism, basically, if you're using a Unix system, or as we're going to make you do today, a Linux system, you can parallelize your operations in this manner. So for so ls start.csv is basically in this directory. I want to see all the CSV files, and I can basically pass it into, I guess that example is quite nonsensical now that I read about it, but basically you can make Python run that CSV file for some reason in that fashion. And the second one is basically a nested version. So you can do a nested for loop in an OS. And what could be the advantage of running OS parallelism? It's basically, OS parallelism is good because your computers are, or your operating systems, or your laptops, are quite used to running things in parallel. You know, you have Chrome up, you have Spotify up, you know, you're running some kind of update software in the background. So your computer is always parallelizing processes and allocating resources. So to a certain extent, the OS parallelizing using your OS or your terminal can be useful, but we're hoping to introduce you to use something better than that. So this is just an R example. Sorry, I couldn't fit into Python one because it just was long. But parallelism in Python and R, if you're interested in some kind of parallelism in using your Python code or R code without getting into Hadoop and Spark, you can use packages like multiprocessing and dispy. So in Python, dispy is more useful when you want to deploy your code in a multi-server environment, so when you have multiple servers that you want to run things on. Multiprocessing is more confined in a single server. So it's more applicable to you guys since you have one laptop, and that's basically like a server. You use multiprocessing. And in R, the parallel and do snow, these packages do basically the same thing where you make a cluster, you then run it in parallel. Okay, sorry. Actually, just later. Yeah. So before we dive into feel that I've missed this to include a slide. I just want to make sure people understand what I mean when I say a cluster. So, these are graph terminology. So if you're familiar with them, that's good. So these are called edges. These are called nodes. And the system together is a network, right? And when I say cluster, I'm talking about, so each point could be a computer or a server. So when I say a cluster, I'm talking about a collection of servers or a collection of computers. And when I say node, I'm referring to each individual server. And so just in case you are confused about the cluster terms, the terms node and cluster come out again in your installations. So I wanted to quickly do an aside about that. So limitations of using OS parallelism using your Python and R is, so both Python and R require embarrassingly parallel. So what that means is, like, adding 2 to everything in your array is obviously something that's embarrassingly parallel, and Python and R are good with that because mostly these operations take the same amount of time. So there's no real issues with scheduling, and not everything is embarrassingly parallelizable. So if you have taken the training program last semester, or if you are taking the training program now, you'll be learning some machine learning algorithms. And not everything in the machine learning algorithm can be parallelizable. Some things need to be grouped together in sequences. And Python and R are not really equipped to do that unless you tell them explicitly in which order you have to execute your processes. Does that make sense? Okay. So, like I said, when things are of different lengths, when the processes that you have to run concurrently of different lengths, they are different processes. Maybe during your process, some things are adding, some things are multiplying, some things are joining tables. So these things, if they're occurring concurrently, they have different lengths. So how much time they spend in order to finish the process. In that case, that becomes a scheduling challenge. So it becomes the computer has to decide, which one goes first in what sequence. What amount of resources will be allocated to a certain process. So when I say resources, it also means memory. It also means the number of CPU threads or cores to assign to a certain process. And as a result, it's not very scalable. So when you have 10 processes, 15 processes, 20 processes, it's really easy to schedule. It's actually, my entire major is sort of, it circles around scheduling and queuing, operations research. But basically, it becomes an easy problem. But once you get into the hundreds, the thousands, tens of thousands, and in an industrial scale when you're doing billions and billions of operations every millisecond, this becomes a non-scalable sort of solution. So, yeah. Wait, can you go? Okay. Oh, next one. Oh, okay. So today very soon we're going to be diving right into installing Ubuntu and Linux. And I want to introduce, the Linux OS system is quite interesting. It's actually quite easy to use. I really like Linux, but why are we enforcing Linux? Specifically is one, it's very lightweight. So Linux OSs, for example, if you download an ISO file to install Mac versus Linux files are always smaller. So Linux actually has a very bare bone structure. So that actually translates to speed. So your Linux OS will significantly outrun your Mac and definitely Windows. And I don't know, the Windows OS is not a very a sexy OS, so to speak. And Linux is open source, so the open source nature is actually quite important. It means there's a community of developers who are continuously working on bettering the Linux environment versus a closed source. And that makes Linux very adaptable to new challenges. So like parallel packages, there's so many parallel packages in Linux, there's so many different types of packages that have different functionalities, and this has been going on for quite a long time. So ever since Linux came out, development has been happening. Also, Linux is very secure. So since it's fast, lightweight, and secure, actually all the servers, or I guess this would be too big of a statement, but most servers being deployed by any cloud computing or any sort of company in the world today will be running in Linux. So it's important for you guys to be able to use Linux. If you're interested in a technical career, which I will assume, since many of you will be engineers, if you're interested in working with servers, and you'll always be working with servers in data science, so if you're using Hadoop, SQL, MySQL, so any sort of database management and big data tool that we're going to talk about today, it will be working with Linux. So you should be interested in working with Linux. Yes?
So are you saying that if I have a Mac, I cannot connect with the server?
No, you can't. You can't. And Macs are a little bit different because Macs are also Unix systems. But in terms of performance, for example, in terms of performance, Linux outruns Macs. So companies, when they actually use Linux systems, they use Linux systems more. That is not to say you can't SSH into these servers using your bash. I mean, but companies will rarely run their actual servers in Mac OS. Good question, actually. So Linux is, that's a good point. So Linux is actually in a class of OS operating systems called Unix environments. And your Mac, if you have a Mac, actually Linux is a very popular cousin, I guess, in the developing world of the Mac OS. Although in real life, I guess Macs are more popular. All right, so today we're going to be making you guys do the left column, which is called dual booting. And I wanted to, before you guys get scared, because when we start actually dual booting, you get all sorts of warning messages like your disk partition will be wiped completely, all your data will be lost, and you have to boot the computer a couple times, and you're not used to that. You have to go to the BIOS menu and then change the boot sequence, and that can be scary. So I wanted to talk a little bit about what that is. So dual booting is basically the idea that when you get your laptops, you usually have a pre-installed OS. If you buy a Mac OS X will be installed. If you have Windows, a Windows OS will be installed. But your computer is actually able to run usually any OS. So if you have a Windows, your computer should be able to run a Mac OS. Actually, I guess not really, but a Linux OS. A Linux OS. I mean, I don't know. I think there are some security features that make the compatibility a little finicky, but Linux, there's no problem. You can run a Linux. So basically, rather than running your Linux system and your Windows system concurrently, you can choose at boot sequence. So when the black screen at the start, or some kind of progress bar moving, or Dell or Lenovo logo sign, you can choose which OS to boot into. Versus a virtual machine is basically you download a software that simulates having another computer inside a computer, and that has its disadvantages and advantages. So why do we choose dual booting over virtual machines? Dual booting has the advantage that your entire computer resources get devoted to one OS. So you're not running anything concurrently. In VirtualBox, you have the freedom to move back and forth between the OS without turning off your laptops. This is quite useful, I guess. I actually sometimes boot into my Mac virtual machine. I have a Mac, Linux, and Windows on my laptop, so that could be useful. Dual booting also, so virtual machines have the disadvantage that you're sharing resources. So a lot of you guys, actually, I guess I can ask now, how many of you have 8 gigabytes of RAM? At least 8 gigabytes. Right, cool. We put that in the requirements. How many of you don't? Today will be your laptop's funeral. It will die, and we'll do CPR. It's gonna be fine. But so if you
Inspire confidence.
I inspire confidence, yes. Using a virtual machine is basically having or using some portion, and in the data science sense, that doesn't really make sense. You want to devote as much resources you have as possible, and if you're serious about data science at all, you really should have a dual booting system for Linux. Yep.
How likely is the dual booting going to corrupt the files of the original operating system?
Usually the operating systems of today have do a pretty good job of reassigning partition space. So usually the partition that will be used for Linux will be quarantined away. So you'll be able to select which partition that your current OS occupies. Hopefully. But I mean, if you follow carefully the instructions that we have today, you should be okay with that. But So when in doubt, so I do want to make this statement here. We're going to be encouraging dual booting, but when in doubt, ask questions. Don't be like, oh, this seems cool. They click, and then your next week's assignment is gone, and so is your a lot of your pictures and everything. So there are risks of that happening. So when in doubt, ask questions with screenshots. I highly encourage that. That said, I guess we're making a disclaimer that if you follow our instructions, it won't happen. So it's up to you guys. Okay. All right, so we'll take half an hour and maybe longer, depending on the panic state that happens, like the chaos that ensues after we start installing Ubuntu. We have about 20 USBs boot.
So what's the minimum space that we need to install?
Okay, that's a good question. So in the requirements that I put up in the events and all the notices, I said 8 gigabytes of RAM and 50 gigabytes of disk space. But that said, you don't necessarily have to have all 50. You can actually have like 20. That's fine. But in all part, like if you think about the actual purpose of your Linux machine, which is to actually do data science, 20 gigabytes is usually too small to actually do, like store any kind of good industrial scale data. So we encourage you to do at least 50. If you have a lot of stuff in your laptops, like hundreds of gigabytes of God knows what, I don't know, like, who knows? Anyways, then you are free to limit the number of partition space. Ubuntu actually recommends at least 15 to 20 gigabytes. That should be your local. But we recommend 50 gigabytes. The number 50 just comes from experience. So you don't have to completely take my word. We're going to download Ubuntu. Are the instructions already on? Is everyone on Slack? Nod, shake, confusion, yell, okay. So everyone's good? Okay, so we're going to be posting material that is relevant onto Slack. Please, we ask a little bit of patience. We didn't anticipate this many people. This is like at least a good 70 to 80 people. We only have 20 boot USBs. So you'll have to wait a little bit. The actual process of installation won't take too long as you don't run into problems and you're not wiping your hard drive as you speak. Okay. So I'm basically leaving these disclaimers because I want to make sure that everyone consult people if they're in doubt. Okay? If you're in doubt, don't wipe things. Okay? Cool. So you guys can go ahead with the instructions now. And I anticipate there will be a lot of questions, particularly if you have a Mac, because the Windows, the dual booting process for Windows is actually quite simple, unless you have Windows 8. So you're screwed. No, I'm kidding. You're not screwed. But if you have Windows 8, there's one more step. But the Mac process can be a little bit more complicated. So you guys can go ahead now. Those are good questions. I think I forgot to mention the Mac. Oh, it's this size. Oh, actually, maybe. It's okay if we wipe this. Okay. Because it will be white. Sorry guys, so sorry for the lack of instructions. The documents are in the announcements channel. Does that make sense? Yeah, announcements channel. Guys, you can start with.
Or like if you haven't used it,
Activate Windows.
Okay, for now we can see what we can do, but sit out in the server installation. Is that okay?
yeah. So like, yeah, you can do like a partition. I don't think we have that. No, I already have. I'm already
Yeah.
Is it going around? So if anyone needs a boot USB, we'll give it to you like as soon as you need it. Okay.
Who is having this problem with USB-C?
Not that many of them.
Does anybody have a USB with a dongle? Yeah. USB-C port on top.
Okay, those with the USB-C problem, please come up with that.
Alright. Who needs a boot media? Who needs a boot media? Okay, we'll start with you.
We forgot to put like markings on those, but please don't take these. Oh.
What was that? There's one for Mac. Oh, sorry. I just looked like a Mac. So go to Windows Disk Management. So find where the disk management is. No, so you find it in your library.
Like they just did that without breaking anything. So I'm like, okay, let's go.
What was that?
I think so.
Oh, you run the install.
No, this is, I have a link. This is the,
Oh, yeah. So, where's the wait? You can follow the instructions.
Yeah, it's in it now.
Wait, who else needs a boot media? Okay. Sorry. So did you do the partition? Do I need to do? Yeah. Oh, just the left. So math one? No, just. Yeah, so you okay. What version of Ubuntu? 16.04. Oh, do you have them?
Yeah, I already have it.
We need it? Okay, what? Wait, some of you will have to wait. Sorry, guys. Okay. I have one left.